Welcome to The Explainer. Today, we're diving into the invisible engine that powers pretty much everything you do online. It's the absolute heart of big data, the cloud, you name it. We are talking about distributed computing.
Let's jump right in. We're going to uncover the core architecture that has to deal with the insane amounts of data flying around the globe every single second.
You know, the source for this explainer puts it perfectly. It says that behind all the big buzzwords, cloud computing, virtualization, big data, there's one single foundational technology. And that is going to be our entire focus today. So, what is this invisible piece of the puzzle?
I mean, really think about it for a second. When you stream a movie, or you're running a really complex analysis for a project, or even just doing a simple web search, there is this huge coordinated dance happening behind the scenes. What on earth makes all of that possible?
This is it, distributed computing. It's a beautifully simple but totally revolutionary idea that a bunch of individual computers, all networked together, can act as one single, incredibly powerful system. And to really get just how big of a deal this is today, we have to look at where it all came from.
To see how we got here, we've got to rewind the clock a bit. The internet wasn't just born overnight. It actually started as a military project designed to solve one very specific problem.
It all kicked off in the late 60s with a military research project, DARPA. The goal was pretty simple: connect scientists' computers. Well, over the next couple of decades, that network evolved. And this is the crucial part. Universal rules, protocols like TCP and IP, were created so all these different machines could finally speak the same language. But the real explosion happened in 1992, when this whole government project was opened up for commercial use. That was the spark that lit the fuse for the global internet we know today.
Before this common standard, the digital world was just chaos. Seriously, imagine hundreds of companies creating their own secret handshakes for computers to talk to each other. These were called remote procedure calls, or RPCs. It was a digital Tower of Babel. The internet protocol just swept all of that away. Suddenly, we had a single, flexible way for computers to share information freely without being stuck in these rigid, totally incompatible systems.
So, the world got connected. Awesome, right? Well, that created a brand new, massive problem. The sheer amount and speed of data just started to completely overwhelm traditional computers. A new challenge came into focus. How do you process these enormous data sets without everything just grinding to a halt?
The main villain in this whole story is a word we've all felt before: latency. If you've ever had that lag spike in a video game or that awkward delay on a video call, you know exactly what I'm talking about. It's that frustrating gap between when you ask for something and when you actually get it. And in the world of high-performance computing, latency is the ultimate enemy.
And the stakes here are unbelievably high. When you're working with real-time data, high latency is literally the difference between success and failure. Think about financial trading or medical diagnostics. That delay isn't just an annoyance, it's a critical breakdown. So the need to absolutely crush latency is what drove the next huge evolution in computing.
And this is where everything changed, all thanks to a massive shift in economics. It used to be incredibly expensive to get real computing power. You had one big central machine, and you could only afford to work with tiny samples of your data. But then, everything got cheaper. Instead of one giant pricey computer, you could suddenly link together hundreds of affordable off-the-shelf servers. This unlocked massive parallel processing and made it possible for the very first time to store and analyze everything.
This economic shift basically made distributed computing the obvious solution. But how does it actually work? How does it deliver that incredible performance? Let's take a look at the blueprint.
Okay, so the most basic building block is something called a node. Just think of it as a single computer. It's got its own CPU, memory, and storage, but it's part of a much larger team. When you cluster hundreds or even thousands of these nodes together, you suddenly have this massive shared pool of resources.
And here is where the magic happens. It's a divide and conquer strategy. So instead of one machine trying to do an impossible amount of work, a massive job gets broken down into thousands of tiny, manageable tasks. Those little tasks are then sent out across the entire cluster, and hundreds of nodes work on them in parallel, all at the exact same time. Once they're all done, the system gathers up all those tiny answers and stitches them together into the one final result. That is how you analyze petabytes of data in minutes instead of years. It's incredible.
So, we've looked at the history, the problem it was trying to solve, and the solution. Understanding distributed computing is absolutely the first essential step if you want to grasp the entire big data landscape. It's the foundation that everything else is built on.
All right, so we've covered the how.
The next logical step is the what. The next chapter in our source material dives right into the specific software components. We're talking databases, file systems, processing engines that actually run on top of this architecture to form what's called the modern big data stack.
And that kind of leads us to a final thought. This ability to connect computers all over the globe to solve problems has already completely changed our world. So the question now is, with this unbelievable power at our fingertips, what seemingly impossible challenge are we going to tackle next? Thanks for joining us.